All right, so continuing on with verifying the trig identities. So you see with number 25 here, this is what we want to verify. So I'm probably going to work this side to get it to equal to 2 cotangent theta. So if I'm going to do that, I need to get these two together, which I could do with a common denominator right now. But I'm going to go ahead and try to simplify this first and get into sines and cosines before doing that. Might make it a little bit easier. So if I do that, I got the cosecant theta, which is going to be 1 over sine theta. And then secant theta is 1 over cosecant theta plus cosine theta over sine theta. And of course, I got my 2 cotangent theta over here. Well, now, when I go ahead and simplify this, of course, I'm going to flip the bottom and multiply. That's going to give me cosine theta over sine theta plus cosine theta over sine theta, which is equal to 2 cotan theta. Now I could kind of see that from the beginning that it would wind up being this, which of course would then give me the same thing in the bottom. It's just a total matter of preference and what you see first, and the more you do, the better you get at it. So now from here, I got cosine over sine, which we know is equal to cotangent theta. And then of course I got it over here, which is cotangent theta. So then our last step, we got cotangent theta plus cotangent theta. That is 2 cotan theta is equal to 2 cotangent theta. And that is good. All right, so looking over here at number 26, I see what I got here, and I'm thinking, all right, well, what can I potentially do? I can try to work this side, change sines and cosines, common denominator. I'm looking over here, and I got the 1 minus sine x, and I'm thinking, all right, well, if I multiply by the conjugate here, 1 plus sine x, then I can use a Pythagorean identity to swap it out. That might make it easier. So that's the route I'm going to try and go with and see what happens. So I'm going to multiply the top and the bottom by 1 plus sine x. So I'm going to go ahead and do that here. So cosine x over, so I already have the 1 minus sine x multiplied by the conjugate. So that means I can multiply the top. Then I still have my secant x tan x over here. So now when I go ahead and multiply out the bottom here, that is with the multiplying difference of squares, that's going to give me 1 minus sine squared x. So I have cosine x times 1 plus sine x over 1 minus sine squared x. Of course, I have my right side. And then students are saying, well, why didn't you multiply the top too as well? Why didn't you distribute the cosine? Because I kind of noticed from up here when I multiply this and get 1 minus sine squared x, I know I'm going to replace that with cosine squared x, and then I can reduce one of those. So I'm kind of thinking a couple of steps ahead of time. So I went ahead and I'm going to go ahead and do that now. Replace my 1 minus sine squared x with cosine squared x. And now, like I said, I can reduce 1 in the top with 1 in the bottom. So that leaves me with 1 plus sine x over cosine x is equal to plus tan x. And now hopefully you can see what's going on here. With this, I can split it up and say that it is 1 over cosine x plus sine x over cosine x is equal to secant x plus tan x, which is exactly what we want. 1 over cosine x is secant x. Sine over cosine is tangent. So we are good to go. This is verified. All right, so let's take a look at number 27. All right, so you can see I put up 27 and then 28. So looking here, I got secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Of course, we're going to work on this side and get it to equal sine squared theta. There's a couple of things that you could do. Some students would see this right here, and they would say, all right, well, secant squared theta minus 1 is equal to tan squared theta, and replace that and work it from there. And that's entirely, that's perfectly fine. You can do that. I look at this and I can say, all right, well, if I split this up and I can say that it's equal to secant squared over secant squared minus 1 over secant squared theta, and I can work it from there. So that's what I'm going to do. I'm going to go ahead and split this up and say secant squared theta over secant squared theta minus 1 over secant squared theta is equal to sine squared theta. So of course this will become 1 minus 1 over secant squared theta. Of course the reciprocal is cosine, so that's going to be cosine squared theta, because it's squared here, is equal to sine squared theta. And then 1 minus cosine squared theta is of course sine squared theta, and that is equal to sine squared theta. So we're good. Now if you wanted to go the other route, like I was talking about in the beginning, so you could say that secant squared x minus 1 is equal to tan squared x. So let's go ahead and do that. So you get tan squared theta over secant squared theta is equal to sine squared theta. And then of course tangent is, it'll be sine squared theta over cosine squared theta divided by secant, the reciprocal of that is 1 over cosine squared theta is equal to sine squared theta. And then when you go ahead and flip and multiply, move this up a little bit more, that would give you sine squared theta over cosine squared theta, and then you would multiply by the reciprocal, which would be cosine squared theta over 1 is equal to sine squared theta. And of course you can see where this is leading. I'm running out of paper. This would reduce and you would get sine squared is equal to sine squared. So it just, you can see there's different routes. It depends on what you see. All right, so now let's look at the last problem here. So this looks like a mess. Got a lot going on both sides. And I guess it really is a matter of preference of what you want to work on. I'm going to go ahead and pick this side and work this side right here, because I know that cotangent squared theta using Pythagorean identity is cosecant squared theta minus 1. And then using the difference of squares, I can factor that and start crossing things out. Again, there's something, the more you do, you'll see things as you're going on, and that's what you'll work on. Maybe some students want to work this side. As long as what you're doing is true, you'll eventually get there. So like I said, I'm going to go ahead and replace this with the Pythagorean identity, cosecant squared theta minus 1 over 1 plus cosecant theta is equal to 1 minus sine theta over sine theta. Now like I said, I'm going to go ahead and factor this. It's difference of squares. So that's going to give me cosecant, put that there, cosecant theta plus 1, a that parenthesis instead of a c, the minus 1 over, and then 1 plus cosecant theta is equal to 1 minus sine theta over sine theta. So now here cosecant theta plus 1 is the same thing as 1 plus cosecant theta. They're the same factors. I can go ahead and reduce them, cross them out. So that leaves me with cosecant theta minus 1 is equal to 1 minus sine over sine theta. So now I was saying, all right, well, how is that going to help me? Well, cosecant theta we know is equal to 1 over sine theta. So if I do that, I got 1 over sine theta minus 1 is equal to 1 minus sine theta over sine theta. So it looks like we're getting close. Anyway, well, we can go ahead and subtract these, get a common denominator, which would be sine theta. So then this would be 1 over sine theta minus, got to multiply top and bottom by sine theta. And that would be this right here on the right side. So now by doing that, I can go ahead and put these together because I got the common denominator, which you can see is going to wind up being the same here. So this would be 1 minus sine theta over sine theta is equal to 1 minus sine theta over sine theta. And we are good. So hopefully this is the last video I'm doing, 28 problems we worked on. Hopefully that's enough that will give you a good example of how to simplify and verify trig identities, and you'll be well on your way to doing it yourself. All right, take care.